So you want to build an MMO. Part 2. This video is a continued introduction to MMO architecture and design patterns. Opcodes. In our case, opcodes are not CPU instructions, but network instructions that are actually represented from in-game client actions. So if these were methods and you were to associate that with network traffic, this would be what we are referring to when we talk about opcodes. On top of that, we may have an expected chain of responses back and forth. We can call this a packet chain. This could be a game action, a client requests to chop a tree, and then their server responds if they approve. You want something flexible enough to handle the different circumstances. You also want something readable enough. That way, in a glancing view, you can just look over the data. For the payloads and opcodes, you don't need to actually use strings. You can always pack those into integers to more efficiently transfer that over the wire. You can also pack the actual data. You don't need to be sending JSON itself. This is not necessarily the network packet itself. You may be just wrapping under TCP/IP or building your own from scratch. This is just an abstract way so we can manage the actual network communication between a client and a server. This model gives us a lot of oversight just into everything on the server and the client. When clients are doing actions, you could see if someone is repeating an action too many times versus another player, if they're sending opcodes out of order, if they're not finishing actually multiple stages of this communication, if you heuristically detected cheating. And now that it's concrete and defined somewhere, you could set threshold values based off of certain opcodes and conditions for logging and alerts. You could get creative. Definitions. Definitions are just files with keys and values. This definition can be in any format, commonly JSON, YAML, CSV, it doesn't matter, as long as you can represent your data. Some don't have nesting like CSV, so you don't want to necessarily go for that. The purpose of your definitions are just so you can have a simple way to associate keys to values that are easy to mutate and easy to sanitize against. Easy to mutate means if it's static in your game, you don't need to compile again to update those values. Also, if it's stored in a database, you don't need to directly update the database with SQL for those records. Our definitions being easy to sanitize because they're plain text. Or Git, whatever we're using is going to show a diff between these files because they're not binary blobs, and it's just easy to read with your human eyes. Between the client and server, we have different needs on the actual definitions. For example, items and objects, we need to know different things as the client versus what the server may let us know. For example, the server definition for items will have the stat bonuses, and the client definition for items might not include that. There are other definitions that only belong to the server, so quests, dialogues, hidden bonuses, things like that. Things that you wouldn't let the client know until you're ready to deliver that as a server. Since we're not exactly sharing a one-to-one of each definition, we're also not going to share the same schemas between the client and server. Therefore, we need to define those separately, if that's going to be the database schema or the expected schema of these definitions themselves. We're going to have that put down somewhere. We do have some shared definitions between the server and client that would be behavior rules that we want to mirror each other, so the expectation between client and the server is the same. Opcodes, the network traffic itself, we want that to be the same. And animations, it may be important for the server to know the timing of animations, things like that. Execution models. Since we're an MMO, scaling is the biggest thing, so our architecture for our execution model is important. We need to understand the difference between processes, threads, and async. For processes, unless you have a way to statically have memory recognized between these processes, and you have these other processes generally just as readers and not multiple writers. Unless you're doing that in a language that you can actually manage that, then when you're using processes, you're going to actually have to communicate over standard in, standard out, which can be a bottleneck of itself as well. The communication between this may cost 10 milliseconds, who knows, just to communicate that. You could batch this communication that you're pulling from, but even then, it may not be the best pattern in all cases. You really want to reserve processes for the simulation itself. If you're doing sharding between regions or zones that players load into, or different instances for dungeons that a player loads into, if you have an expensive operation that doesn't need to be performed quickly in succession, and also doesn't need to share memory space, even with the batching, you may not overcome the actual cost. But if it was, say, the database queue itself, that could be something where the message queue, putting that message on the queue is actually pretty cheap, since that can be done in a large batch. And writing to a database or updating the database could be more expensive in a lot of cases. Using dungeon instances as an example, we may want to have a pre-fork worker ready to go, maybe several pre-fork workers. We dynamically scale this based off of expectations. These could also be remote workers entirely, since we just need to transition the player between these. Threads and async. A thread runs inside a process, and simply the operating system can pause one thread and run another. This makes threads useful when something is blocking. If you have a blocking operation or multiple blocking operations, then having more than one thread, 2, 3, 4, would make sense. If you have no blocking operations at all, then threads are not accomplishing anything in this sense, but still may be useful for spreading CPU-heavy workloads across different cores in parallel. Async, on the other hand, does not give parallelism, it gives concurrency. You wouldn't use async for something like pathfinding, anything heavy computation-wise that you need to wait on a result from. You would use async for something like 10,000 network sockets, where specific sockets become ready and you need to efficiently context switch between these sockets. Indexes. Without overcomplicating things, the important things to note are really the cost of access, search, insert, delete on our server data at scale. The scale could not just be the number of entities, but the clustering of them, how quickly those move, or the time it takes to scan before you can mutate a node in these data structures. With that in mind, we specifically want to look at spatial data structures just to complicate things. But don't worry, we have some key takeaways. This is a table with a lot of information. The key takeaways, and what I'd use in Egg Engine, we use a chunked spatial hash for dynamic entities. That would be players, NPCs, monsters, projectiles. And for static objects, we use an R tree. If your map's collision points are not going to change, then there are better options than an R tree. If you're going to have really high volume of clustering, then a quad tree would be better than a spatial hash. If it was static one-dimensional line collision, then nested containment lists, which aren't even on this list, would be better than everything.